Chat. Oh, here we go again. Here we go. What's going on, boys and girls? I hope everyone's like really relieved after all their maths exams are over. Some of you probably will never do maths again in your life. Imagine that. Probably should get my document ready. So I guess the vibe of this paper will be a bit different. I haven't seen the paper. We're going to do it in exam conditions, but I'll try my best to actually write something that's, you know, you can put on the YouTube a bit later on, and so it actually set out properly rather than just a lot of panicked scribbling towards the end. So that's our goal for this particular session. I'm going to quickly get through it, and then we'll be off for another year. Hope everyone went well today and didn't get any surprises. I haven't actually seen like what topics they decided to put the hard questions on, so we're going to find out during the reading time. We're about 5 minutes out from reading time. I'll just write the heading, I guess, in my writing paper. I did this a couple of hours ago. Let's see how many I got wrong. Hey, that's what we're here for. Only 2 hours ago, I thought the exam finished at 12:30, unless of course, you know, those 4 hours felt like 2 hours for you. That's all good as well. Yeah, I had to stay at work, so it took me a while to get home and get this set up. So, you know, bro, the test was easy already. Bob Ernie even. Half the questions are from advanced. Sheesh, okay. Guess we'll be done in an hour and a half then, eh? Okay, so 2024. Extension 1. The thing about I find with Extension 1 exams is that given how short of time you have, you've only got 2 hours, it's actually not that easy to get all the marks in 2 hours, and especially considering that if you do Extension 2, it counts as 2 units. Which means that you end up having, you know, it count a lot for a 2-hour exam. Ali's laboratory, nah, that was free. Just that stupid last projectile. Oh, we got some spoilers already. Projectile for the last question. I had some there was some commentary and chatter yesterday on Board of Studies where people were saying, yeah, they haven't done projectile for a while, so they were going to do it. I guess they did it then. Nessa is doing us nicely this year, eh? Okay, all right. Although honestly, like the 4-unit paper was okay as well. I mean, there were enough things that everyone can get marks for. I just haven't been bothered to actually do those last few questions. Okay, we'll start the reading time in a few minutes. It's not going to scale as good this year, you reckon? That's usually what happens when everyone's averages are quite high. I mean, you can argue that I think students who studied hard deserve to have, you know, access to some of the paper. If you make it too hard, then that's not going to happen. So you could say, yeah, it's a good thing that it's not super hard. I think we got another couple of weeks of HSC left for everyone who's actually finishing their HSC in 2024. I think we got some physics right towards the end. It's always been like that. Would you say the Extension 2 will scale like 2023? I think from all indications, it'll scale not as good. As in, like, you're probably going to need a high 60s to get the E4 this year. Yeah, a high 60s, like maybe 67, 68. You could scrape into an E4 with a 68 raw. But who knows, right? Like, depending on how they market and the kind of people that do it. I think their goal is to make 40% of the candidates get E4 in Extension 2. I think that's round about the percentage of people who get the E4 from doing that course. So, just turns out that way. Get myself a pencil for the multiple choice. Let's get to it soon. Hey, before we get started, what are people doing for uni? What's the vibe here, guys? Like, is it STEM these days? Are people into STEM going into uni, or is it the same old, like, you know, commerce, law kind of stuff? You know, whatever makes money. What's everyone's leaning towards? Computer science and maths? That's pretty cool. 5 years. I mean, I think computer science is where it's at now. I think if you've got a very sort of algorithmic and logical mind, like, you can't go wrong with something like that, because, you know, if you can go into a job and show them that you can problem solve, like, you're going to be able to get a huge variety of roles. So yeah, that sounds like a great plan. All right, well, we got to start the reading time. Let's actually have a look at the paper and see what's going on here for 10 minutes. So saturated, everyone does computer science. Yeah, I feel like you're going to need a lot of networking connections and things will help you as well. So I think it helps to, like, know people, so that way you can get into a variety of different roles. It's not just about, you know, being really good at you know, the maths or the coding or whatever. Okay, so we got some of this inverse functions. I'm always curious, because when they get to, like, questions 9 and 10, they've been doing some like inverse functions rubbish lately, which they haven't done this year. Okay, it's got some sample proportions on the question 8. Okay, a little bit of like interesting. A lot of different options for the probability that two coins are joined of the same metal. Okay, so that sounds like a bit of a probability thing going on here. Maybe binomial, but we don't know. I haven't really read it in detail, so I'll check it out in a bit. What is this? They got like a bit of an auxiliary angle options chasing. Kind of weird, not gonna lie, right? So I'm sure it's very doable compared to some of the inverse gradient business that they've been getting up to lately. Okay, so very standard looking question 11, nothing weird. Yeah, okay, so very doable. They love their arc sign notation, inverse sign, which is interesting. Okay. Yeah, rate of increase. So question 11, very standard. Question 12, pretty straightforward as well from the looks of it. Oh, they still love that. They still like this whole standard normal approximation. I mean, people can't stop arguing about the stuff about, you know, continuity corrections, because some textbooks use it, but NES is happy to accept ones without continuity corrections. So this one, extremely standard divisibility, because it doesn't even have another power. So surely nothing can go wrong here. They've given you a graph of over here. It's already got an absolute value sign, so you don't even have to do that. And they want you to... Okay, so it's 3 marks for doing some stuff. There's some stuff. You've got to, like, make an equation of a line or whatnot. So I guess we'll find out if it's time consuming. Slope fields. You know what? I hate slope fields. I don't know what it is about slope fields, but it's such a vague thing. You know, it's like, yeah, pointless. But because they put logistic equations in the question 13a, it's not going to get any harder from here. So that's, you know, for people that are hoping that they get logistics at you know, question 14, not happening this year, unfortunately. Sorry about that. Okay. And 13b, a bit of trig identities with the integration thrown in. Nothing crazy. Vector projection also thrown in as a nice, oh, it's a 4 marks. It's nothing to scoff at, so we'll find out. Here they provide the substitution, very nice of them. And if they provide the substitution, surely nothing will go wrong in part D, right? I mean, you know, like it looks like it's got multiple powers going on. But they're giving you the substitution, so YOLO, I guess. Okay, Z table, really? Why did they? Oh, they gave you a Z table. It's amazing. Okay. How did 3 unit turn into 2 unit? When did that happen, guys? When did 3 unit devolve into advanced? Oh boy, oh boy. All right. Find the domain and range. Now, with extension 1, I do spend a few minutes looking at these questions and finding out if they're approachable. Okay, so we'll have a look at each of these 14s and see if like there's anything that we need to sort of think a little bit about. Okay, find the domain and range of the function that is a solution to the differential equation and whose graph passes through the origin. I mean, for 4 marks with not much scaffolding, it's a little bit concerning. I think that the idea here is that the trivial solution might be, yeah, you know, we have to do it to know what happens. Obviously, I can't write at the moment, so we're gonna have to, yeah, get this. Regard reckons epic easy 100. You reckon? And you know, when I did the HSC back many years ago, I don't think I got 103 unit. 3 units hard. Like the time pressure is too much. Like 4 unit, you can like, you know, cruise along in 3 hours and trying to get the hard ones out. 3 unit, like if you get bogged down on one question, like there goes 100, dude. Yeah, Ragard reckons he got 100. Sheesh, okay. Everyone step back. So for what values of the constant k will the function have an inverse? Okay, so this sounds like one of those horizontal line tests. It's interesting. I'll give it that. We're gonna have to like interpret it in a graph somehow before we even get going with this, because clearly something's up with this, and it's to do with the sum of 2 graphs with perhaps you know, having to think about the horizontal line test upon drawing these graphs. Explain why the equation has exactly 1 solution. I mean, I feel like these questions, you know, people are like, oh yeah, tambo sides, whatever, blah blah blah, and why is it even called an equation? Guys, is this like weird? Is it me, or like I'm looking at this and I'm thinking, what do they mean by equation? Oh, they mean like for any theta, regardless of what theta is, it has exactly 1 solution. Why? Why would that be? Huh. Fascinating. So I'm guessing another graphing question? Weird. Thetas between minus pi and pi has exactly 1 solution. I mean, look, honestly, I have a feeling that if you just sketch it and be like, okay, the sum of these graphs is 1-to-1, it should be fine. Okay, nothing crazy here, and then we just solve it. Hey, are we vibing, guys? Are we vibing that question 14 is like literally free? With like some marking details here and there where you might get docked a couple of marks here and there. You know, it's not graphing trust. Regav is like questioning my insight on the graphing. Okay. Alright, bros. And D, particle is projected from the origin with initial speed v at an angle of theta to the horizontal. The position vector of the particle where blah blah, oh, I hate this notation, but whatever, is given by the x and y values there. Let b be the distance of particle, so yeah, okay, sure. So, show that theta, which is the angle of projection, is less than, show that for theta is less than this, the distance is increasing for all time. Okay. Why that particular angle? That's a really special angle, which is pretty cool. Imagine if you had this in 4 unit with a bit of a resistance going on, how hard that question would have been, right? But they've chucked it in 3 unit this year. I'm just having a think about this and I'm going, yeah, okay. Theta is less than that angle. Distance is increasing for all. To be honest, I almost feel like this is just like a differentiation. It's like you put like the distance into the magnitude formula, right? And then you just kind of go, oh yeah, if we differentiate it, we can show that the derivative is positive for this particular value of sine. Like, come on, I don't really think it's like very obscure what they want you to do here. Like keywords increasing, okay? Keyword dt is the magnitude of this column vector. Like, what could possibly go wrong, right? Comes in at the end. That's what I thought too. How that angle would be relevant comes in at the end. That's what I did, just brute force differentiation. That's what I mean, Matthew. Like, I really don't think there's massive insights in this question. We're going to have to just obviously make it to this question and attempt differentiation. So, I would say 14 looks very accessible. Like, there is something for everybody here. Out of 14 marks, you know, I reckon people would be happy if they can get at least 8 or 9 out of 14. Okay. Yeah, obviously there's a lot of graph related questions on 14. Are we all chuffed that there's no sample proportion or maybe even like the gradients of inverse functions? That thing is insane. Like people struggle to even like explain it to students. And gradient of an inverse, they didn't do any of that this year, so hopefully this has been a nice paper to do. All right, so we're up our writing time. Let's do the multiple choice real quick. Question 1. Polynomial has zeros. What is the value of alpha? So we'll do the sum, which is -2. So -1 -3 plus alpha equals -2. That's -4 plus 2 is a 2, if I'm not mistaken. Yeah, sometimes I get these wrong. B. So 1 is B. 2. Consider these functions in the region shaded in the diagram below. Okay, so which of the following gives the total area of the shaded regions? Are you for real? Like, they want all these regions separately. Let's have a look. Clearly all these -4 to 4s are out because you're not ever going to get something nice from this. Let's just make sure we clearly identify who's the F's and who's the G's. So the G's a straight line. Alright, between these two, we're going to have to check out whether, let's just look at the first one. The first one, they're the same. No, they're not the same. So straight away, I'm not even going to bother looking at the rest of them. So -4 to -3, with the G being higher than the F. So there should have been a G of X minus F of X because one's higher than the other. And then they decided to put a minus sign outside because they wanted to be funny. So I guess it's going to be D. Yeah, I guess so. And then the rest look about the same. So they just wanted to test your negative signs for this one. Just one more check from -1 to 1. Yeah, again, so we have those guys. Okay, this has to be D. So number 3, students come from 4 different schools together to form a choir. I'm actually surprised they didn't go for like a hard, probability, demonstrate the sort of combinatorics question in this paper. Students come together from, okay. What's the minimum size of the choir to know that there must be at least 20 students in the choir from one of the schools? So basically, you take 19 and you times by 4 and you add 1. So that's going to be 76 plus 1, 77, right? Nothing crazy here because you want 20 students from one of the schools and there's no weird like, +2 kind of situation, unlike one of our HSC question 10s from I think 2020, 2021. Okay, so nothing crazy here. What are the domain and range of this function? Now, we know that for inverse cos, the 2x is, 2x has to be between -1 and 1 anyway for these guys. So it's either A or B. And let's look at the range. So for doing the range, what I would do is just play it safe and draw the inverse cos graph, which has doubled in the height. So it's going from 0, normally pi on 2, so it's going to be pi and 2 pi. And the inverse sine graph is going to go like this. Yeah, from -pi to pi. Okay, and if you were to add these, what's the highest value you can get? Let's have a look. You got 2 pi and you got a -pi. So the highest value you can, what is this? Hey, hold up. I mean, guys, we know this is pi on 2 times 2, right? I mean, like, let's not kid ourselves here, but I'm just fascinated by the fact that maybe they made the students want to like try to add them or something. I don't know, like, what is the deal here? So 4 is A. I'm taking too long on these. But yeah, 4 is A because they add up to a constant as well known as a result. And if you were adding coordinates, you'll soon realize it's a constant. So don't get sucked into like 3 pi. There's no way we can get up to 3 pi with these graphs. So it's A. Consider the function. Consider the function. What transformations have been applied to this function to obtain g of x? Advanced maths, hello, okay, cool, we'll do advanced. So looking at the, they did the vertical first. Yeah, vertical dilation by a scale factor of 2 and a horizontal dilation by a scale factor. So, like, why do they sneak an advanced question into question 5? I don't even know. And also there's debate as to, like, how do you do a transformation applied to a graph? Because ultimately transformations are applied to a number plane radiating from the x or y axis. So this language is pretty scuffed. It's not very mathematically correct, but whatever. How many real values of x satisfy the equation? Absolute value of b, and b is not 0. What are they on about? Let's have a look. We got a sine 4x, so the period is 2 pi on 4. Okay, so on pi on 2, we've got several values like this, and I feel like every single one is a sine graph. Yeah. What's this about? And b is not 0. Oh, hold up. We just divided through what? Wait, what? So I guess you could have this one, this one, this one, and this one, and there's 4 down below as well because you care about those, because you know, b could be like, yeah. What's the big deal? Yeah. I'm just thinking about it. And if you have the graph upside down, you get the same scenario. So we're gonna pick D. Pretty confident it's D, but it's something just, you know, like, if you want to thoroughly get it, like, I don't know, you have to maybe prove it or something by drawing the other way around, just in case, right? Or you can, you know what, because it's a B sine graph, you could just draw these guys up. You just absolute value it up, and you get the 1, 2, 3, 4 graphs up there, and that's also, yeah, that's also B. Great. So 8. 30 multiple choice questions, each with 4 options. At least 29 correct to pass. Oh, okay. So correctly answers the first 25. So we already know that. That's out. So we don't even have to consider the first 25. What's the probability that the applicant will pass the test? We're going to randomly guess the last 5. What is the point of asking it like this? Strange. Okay. So to fail the test, we're going to have to we'll pass the test. So you need to get 4 out of 5, and each with 4 options. Let me think. So you need the probability of the random variable being at least 4, greater than or equals to 4. Is there a better way to do that? Well, greater than or equals 4 means 4 or 5. You can't really do it like a complement, because if you try to do it like a complement, you basically have to, yeah, because it wouldn't be the complement. Like, you can't get all of them wrong. And if you get all of them right, that's one of the cases. So case 1, they get all correct, and that's 1 out of 4 to the power of 5. And case 2, you get 4 correct and 1 wrong. So 1 out of 4 to the power of 4 times 3 out of 4. But you have to do the binomial thingy arrangement. So if 5 choose 1, you've got to choose the one to get wrong. That's going to be 1 out of, do I know my powers? 64, 256. It's quite large, like 1,024. And down below you got 1,024 as well, times 3, so 15 over 1,024. And you got 16 and 1,024. What would that be? 64. So I guess it's C then. All right, great. So yeah, so like a little binomial question with some calculations thrown in question 7. A local council is proposing a ban dog walking on a beach. It's known that the proportion of households of a dog is 7 on 12. So P equals to 7 on 12. Wishes to poll n households about this proposal. Let P hat be the random variable. Okay. I mean, like, do I know my formulas? I mean, I know the variance of P hat is supposed to be n P 1 minus P over n squared, so that n goes into the bottom, so it's like n like this. So the standard deviation of P hat is going to be the square root of that. Yay. Okay, so what's the smallest sample size m for which? We got 7 on 12. So 7 on 12 times 5 on 12 over n. And we want this to be less than 0.06. We multiply the root n over to this side. I'm just going to grab my calculator here. So 7 times 5, 35 on 144. And yeah, cool. And then we square root that. 0.493. Divide that by 0.06. And then square it. Oh great, what did I get? Square it. 67. Oh. Okay, now look at this. This is 67. So we know that n is greater than 67.51. Okay, so we're gonna have to pick 68 because it says smaller sample space for which it's like the standard deviation less than. So you want to actually grow the population enough so that it's actually greater than that number. So we're gonna pick 68, right, for that one. Okay, metal coins. N is greater than or equals to 3. So there's that many coins from silver or bronze. There are K silver coins and the rest are bronze. Okay, so you got K and this is silver. And you got N minus K, which is the bronze ones. Okay. 2 coins will be drawn random from the bag, with the first coin drawn not being replaced while the second coin is drawn. So if you were doing this and you were doing a non-ordered selection, because 2 coins, right, unordered selection, you would do it as N choose 2. And which of the following will give the probability that the 2 coins made of the same metal? So what will happen is you simply have to draw the 2 silver ones, and the other cases you draw the 2 bronze ones like this. So it's whichever one sort of simplifies to this. If you were doing the P method, it'll be some other working. I'll show you the P method working in a second as well if you like to think of it like that. So we're going to have K minus 1. Oh, come on. No, I don't really like... Okay, whatever. I'll do it quickly. So this is KC2. N minus K minus 1. That's N minus KC2. And this is N times N minus 1 over 2. So it looks like one of them does match this. And I'm very happy to pick A. Like, I really don't think there's anything else. But let's just do the ordered selection method, which is pretty much the same thing. Like, you basically just remove the 2 factorials and you're selecting 2 distinct coins. So if you did the P method, NP2, you're going to on the bottom get N minus 1 anyway. And on the top, you're going to pick 2 coins in some order and you respect their order. So it's going to be K ways of picking the first silver and K minus 1 ways of picking the second silver, or N minus K. Look, it's the same thing. Like, I don't know what those other options are, like, and what the point of all this is, but I'm just going to quickly check. K minus 1, N minus K minus 1. Yeah, sure. I mean, okay. Why did they do this one? Like, what's all this gaslighting going on? Why are they giving us all these other ones? Am I not seeing something? Let me just check. Not in the second coin, and they're the same metal. So why would they do an NP2 and yet do choices on the top? It doesn't make it beggars belief. Like, I don't know. I'm just gonna lock in A, okay? And let's look at question 10 now. How are we going for time? We're about 12 minutes in, so not terrible. For real numbers A and B, where blah blah, we can find numbers such that auxiliary angle can be written in the 4 forms. Yeah. Okay, cool. we're going to find the 4 angles where r is greater than 0, okay, as usual, and this is between 0 to 2 pi. So look, the way I see it with these questions is that you've got 4 particular positions, and if you've done enough of these, you would know that like depending on the size of A and B, and they didn't really say, did they? They didn't really say. So what you can do in these questions, right, is in order to find one of these answers, because there's only one correct answer, you can just make, without loss of generality, A is greater than 0 and B is greater than 0. Just pop that in, right? So what will happen is that your when you're actually doing the combinations of all of these, so for example, in option number 1, you're going to have r cos alpha equals to b, r sine alpha equals to a. And then if they're both positive, this is the first quadrant angle, okay? But I'm kind of concerned about the others. Let's just check. We're going to actually go through each one. So this one, sine x, so we got minus r, oh gosh, sine x, no, r cos beta equals b, and minus r sine alpha. I'm doing this a little bit on the quick here, equals a, okay? And option 2, option 3, we've got this one. Now this one's a little bit suspicious because it's got a minus sign going on. R cos gamma is the A, and then minus R sine gamma is the B. Oh, that's a little bit scary right now, because I'm sort of vibing that something bad's happening here, because these angles, they're not all matching like these guys. These guys are. Yeah, okay, all right. Did anyone enjoy this question at all? Or is this just like one massive scam? R sine delta equals to B. Yeah, I'm vibing that. Okay, so is there a nice way to do this? A, B, yeah. I'm not looking up at chat right now, guys, because I just want to be able to figure this out for myself. You want to add the 4 angles together. Like, I mean, surely it's nothing crazy, right? You got. Why don't we just make up a number, guys? Why don't we just go like this, half? Let's chuck that in, guys. Let's just make up stuff just because we can, okay? And no, so B over R is a half. Yeah, let's just pick B as 1 and R as 2, you know, because it's got to be one of these answers. So by doing it by example, not something you can ever do in 4-unit maths, right? You can be like, oh, okay, alpha is pi on 3. Beta is, wait, what is it? Pi on 3. Yeah, and then gamma is this one over here, a half. Oh, it's in that weird quadrant. Oh, I hate when this happens. Oh gosh. Yeah, we can't. Can we even do this? What have I done? All right. Let's just check quadrants. This is pi on 3. Beta is not pi on 3, guys. Everyone, calm down. It's the related angle. So so we've got a negative. Sine is negative. Cos is positive. So this is negative pi on 3. Okay, this one. So sine is negative and cos is positive again with a half, pi on 6. And lastly, they're both positive again with, oh man. Yeah, right, okay. I mean, I'm gonna have to say it's 0, but just cause like, is there an elegant way of doing this? Why is this question so bad? Look, I'm gonna put the answers up for the multiple choice. So here's what I got for all of them. We got a 0 for question 10. So that will be an A. And 9 is A. 8 is B. 7 is C. 6 is D. I'm not a fan of that question 10, to be honest. There was no like real concept there. 5 is C, unless like you want to like look into it more later on afterwards. 4 is A. 3 is B. B, and 2 is D, and 1 is B. Okay. I'm happy to take any suggestions if I made an error, but these are the multiple choice answers I've got. How can it be A all or greater? No, buddy, there could be negative. Oh yeah, shit. Oh yeah, true. Oh, thank you for that. We're gonna fix this up, guys. This is gonna be 5 pi on 3, and this is 11 pi on 6. Let's fix up number 10. Adding these up now, we're gonna have 2 pi plus another 2 pi. All right, my bad. It's D. Okay. Thanks for that, guys. We just missed 100%. We just lost state rank. All right, guys. Awful. Any other errors on the multiple choice? Whoops. Guy can't even solve like his what's it called? Auxiliary angles. You know what it is? You know what made me like do this? It's because I'm so focused. Like, this is hot cope right now. I'm just so focused on like the quadrants they're in that I totally forgot that they're forcing you to use a like a fourth quadrant actual like answer up to 2 pi. Like, what an artificial question. What a crap question. Like, guys, in chat, if you have any like suggestions on how this could be understood in a more elegant way, apart from just doing a example, you know, solve by example, please pipe up. I want to know if there's like this clever way of doing question 10 that's not like outright just working it out. Kodo Rig, what do you reckon? Oh, geez. All right, everyone else, Mohammed reckons all good. Thanks for that. Let's move on to the written parts. Okay, so question 11. Consider the vectors. Now I'm just gonna like speed through these quickly because I just want to get up to like the last question. So find 2a minus b. Gonna have 6i plus 4j minus bracket minus I plus 4j. I mean, I guess 7i, I guess, question mark. Okay, all right. Minus signs happen to all of us, I guess. Number 2, find a dot b. Okay, so a dot b equals to 3 times minus 1 plus 2 times 4. Minus 3 plus 8 is 5. Amazing. Question B. X squared minus 8x minus 9 less than or equals to 0. X minus 9, x plus 1. This is, yeah, don't mind me. I mean, like, we all have to get through this part of the exam, right? So we draw a parabola, I think, or you can do the test critical values, but you want this to be less than or equals to 0. So that means we want an interval. Oh, they didn't really specify. So minus 1 is less than or equals to x is less than or equals to 9. And that's your solution for that. Question C. Using the substitution u equals x minus 1. Okay, so integrate. We got x minus 1 dx, u equals to x minus 1, du equals to dx, and x equals to 1 plus u. So we're ready to chuck everything in. So you got u plus 1, square root u, du, and that equals to integrate u to the power of 3 on 2 plus u to the power of a half du, which equals to 2/5 u to the power of 5 on 2 plus 2/3 u to the power of 3 on 2 plus c, and u equals x minus 1, so we put it back in. 2/5, 5 on 2, 2/3, 3 on 2 plus c. All right, D. Use the differential, solve the differential equation. So we got dy dx equals to xy. Separating the variables, we're going to bring the y to the other side. 1 on y, dy equals to x dx. Integrate. So ln, absolute value of y, equals to half x squared plus c. And they didn't even They did say y is greater than 0, so I guess we can just like leave the absolute value out. Express in the form. So we're going to have ln y equals to a half x squared plus c. Did they want it in any particular... It looks like they just cared about this. They didn't even want you to bring a constant out to the front. So we can just leave it like this. Didn't give any initial conditions, so I think we can just stop here at the plus c, just on the power there. No need to make it a. So yeah, what a weird question. Interesting. All right. Okay. E, differentiate the function. I rarely write arc when I'm like at school. It's such a weird way of writing it. F dash equals to 1 over the square root of 1 minus x5 squared multiplied by the chain rule, 5x to the 4, and we got 5x4 over 1 minus x to the 10. Alright, and that's 11 out of the way. Oh, there's more 11. How many of 11s do we have to go? F. Volume of a sphere. So we've got a sphere. They want the rate of increase of radius. So dv dt equals to dv dr, because they gave you volume with radius, dr dt. V equals to 4/3 pi r cubed. dv dr equals to 4 pi r squared. And then we chuck that all back in, dv dt. Hope this is giving us, what, 2 marks? Okay. So a bit stingy on the marks on the first section there, dr dt. And obviously we're going to sub in, oh, they gave us some weird number. The volume of the sphere, so we got a 10 over here. And the rate of increase of the radius. What? Oh, bizarre. So we just kind of like put 4 pi r squared on the other side then, and they didn't even care about the value of r. So what I'm getting the vibe of is that in order to be stingy with the questions and cover more of the syllabus, they basically given us all these like half-baked questions so that we have to only get limited marks for them, and they're not giving like 3 marks away like in big chunks, which is an interesting sort of like approach, I guess. I've sort of never got that from a 3-unit paper before. Yeah, okay, interesting. The region bounded by the curve and the line is shown. Find the area of the region. Yeah, advanced. Is that someone commented earlier that this whole thing feels like advanced? So area equals integration from 0 to pi on 2 of the top one, so x minus sine x. I don't know. I cannot see how this is extension 1. What's up with this? Why is this extension 1? Half x squared minus plus cos x, I guess. 0 to pi on 2. A half pi on 2 in brackets squared plus 0 minus, got to be careful here, a half times 0 plus another 1 with the inverse, with the cos. So we get pi squared on 8 minus 1. I'm always paranoid when I do these evaluation questions. It's never my forte. So I'm going to quickly check again. X minus sine x, half x squared cos x. Yeah, okay, differentiates back into minus sine x. I'm okay. I'm feeling safe. Okay, we're in a safe space. And I'm just chucking in the half pi on 2 or squared plus 0. Yeah, that's pi squared on 8. And the other one is minus 1. Units squared. All right. Done. So that's a question 11. Question 12. Very calculations heavy paper. Calculus heavy or calculations heavy? I'm not sure. Let's have a look at question 12. The vectors are perpendicular. Okay, so we take the dot product and make it equal 0. A squared, a plus 5 plus 2, a minus 4 equals to 0. A squared, no, a cubed, plus 5a squared plus 2a minus a equals 0. Wow. No, why? Alright, we'll test a equals 1. we get the left-hand side equals 0, and that is correct. So a minus 1 is a factor. We divide it through. Hey guys, I remember how to do synthetic division now. It kind of goes like this. You just put the root here, and you go 1, and then like you copy the 1 down. 1 times 1 is 1, and you add, so you get 6. And then 6 times 1 is 2, so you put 6 there and you add and you get 8. And 8 times 1 is 8, and hopefully that gives you a 0, which is a remainder. And so we know that this thing factorizes it into a minus 1 and a squared plus 6a plus 8 equals 0, a minus 1. I mean, you could have done further factor theorem testing, but a plus 4 equals 0, a equals to 1 minus 2 minus 4. I'm just going to quickly check the domains. No issues there really. That's just 12a. Long division, very calculus heavy paper. All right, gotcha, Mohammed. I hope you found you did well. Like I'm hoping like you're feeling like a good raw score from all this. They want a volume of revolution. Here's another calculus question. I'm just gonna quickly sketch it just in case I missed anything. The x-axis and the line x equals 1 and x equals 2. So we got this, the cube, 1 and 2. And what is this? Is this used to be 2 unit or what's the deal? Like v equals to pi, the integration from 1 to 2 of the function x cubed squared. These are like really easy, but hey, no one's complaining, right? 1 to 2 x to the 6 dx, 1/7 x to the 7, 1 to 2, and you got pi 128 over 7 minus 1/7. So 127 over 7 pi units cubed. Okay. Bit of brain rot I'm feeling here. Charity employs a worker to connect donations. There's a 0.31 chance when the charity talks to someone, a donation is made to. Each day they must talk to exactly 100 people. Okay, used its standard normal distribution and the information on page 13 to approximate the probability at least 30%, 5% of the people. So we're going to do the, so this is x. X is the number of donations. And x has a binomial, it belongs to a binomial distribution. Which order does it go again on the reference sheet? Is it the number of trials first or the what's his face? Yes, the number of trials first. 100 trials and the chance of a 0.31. So we got the binomial probability there. We know that the standard deviation is going to be the square root of n p1 minus p, which is 100 times p times by its complement, 69. And just going to quickly work that out on the calculator. So 100 times 0.31 times 0.69 and square root of that, 4.62493 ... At least 35% of the people. Now, I know that you could do this with sample proportion method, but we're going to say that the probability of x is greater than or equals to 35. And honestly, continuity correction is not really a big deal here. So like they don't seem to mark it that way. And we don't have to be too concerned about that. We're just, hey, 35 is the score. So remember, when you're using the standard normal table, you're going to have to like just, what am I drawing? What is this? Let's do the mean first. 31, okay, z score, 35, take 31 over the standard deviation, 4.6249. I've got that on the calculator still, so we're going to take 4 divided by that answer equals to 0.864877 ... And just remember, on the standard z table, we are going to get the area to the right of the mean, which is 0. So 0.86 is around about here. And what do they want? At least 35%, 5%. They want this area. So let's got to be really careful when we go through the table. So 0.86. It's kind of like halfway in between though, which is kind of annoying. 80. Which one's it closer to? 8.6 versus 8.7. It's closer to 8.6, but why is it so in the middle? 8.051. So probability that Z is less than 0.864877 equals to 0.8051. So we're going to take 1 away from that. I'm just a bit worried about the standard deviation, unless I've made a mistake. 0.8051 is therefore probability that x is greater than or equals 35 will be the complement of that, which is 0.1949, which is about 20%. Did they say? No, they didn't. I'm just going to quickly check the standard deviation again. 100 times 0.31 times 0.69 square root is 0.642, yeah. And then we have a 4 because 35, 31, 4. Yeah, I know it's about 4. Whatever. It is what it is, guys. About 20%. Okay. D. Use mathematical induction. Yep. So proposition at n equals 1. So P1, we're going to test P1. 2 to the power of 3 times 1 plus 13 equals to 8 plus 13, which is 21, which equals to 3 times 7. That's therefore P1 is true. Assume for pk, right? So for n equals to k, honestly, this p, like proposition notation, is a bit over the top. Honestly, like I've never used it in the past. Assume for n equals k, the 2 to the 3k plus 13 equals to 7m, where m is an integer. So required to prove for n equals to k plus 1 that 2 to the power of 3 bracket k plus 1 plus 13 is a multiple of 7 where p is an integer, and the left hand side is going to be 2 to the power of 3k plus 3 plus 13, which is 2 to the power of 3k times by 2 to the power of 3, which is going to be an 8, by the way, and 2 to the power of 3k. Now we're going to go over there and take the rearrangement of the assumption, which I forgot to do earlier. Normally I remember to do that, which equals to 7m minus 13. So 7m minus 13 times 8 plus 13, which equals to 56m. What is this? 91? Should I just write? No, let's do 104 plus 13 just to some working. 56m minus 91, which factorizes out by 7, so 8m minus 13, which equals to 7p, since 8m minus 13 is an integer. Therefore, statement true by mathematical induction for n is greater than or equals 1 by mathematical induction. All right, that's done for question D. Question E. They've given us the graph of the absolute value. They want to know this. So what I want to do is I'm quickly going to go back to the question screen so you can have a look at the questions. When would you be solving? Oh, I've kind of skipped advanced. It's been a week. So light, unfortunately, I'm not going to do a live sort of attempt of advanced. Don't quite have the energy left after like my full-time job as well. Apologies for that. Did you get an answer for 2024 extension 216? No, I have actually not finished that question. I did write up the solution for the extension 216B, but Nicholas is looking at 71 out of 70. Sheesh, okay. TiWeb, yeah, papers on BOS, Border Studies, nice. I remember I had done 8 of these exact same questions before, the most free paper they could have given us. Yeah, normal distribution questions are all the same, LOL. Now we're up to 12 still. We're still finishing 12. X on 6. So x on 6 is a straight line with a gradient of 6. So I'm guessing that they're asking us to find all these intersection points, and there's about 3 of them. So let's do that really quickly. So let's go. X on 6 equals. Look, at that point, I'm actually sort of, I like this idea that they make you solve this. So we're going to have to solve the critical values of this and suss it out, right? Let's do it. Case 1, x minus 5. So we put this in, you're going to get x squared minus 5x equals to 6, x squared minus 5x minus 6 equals to 0, x minus 6, x plus 1 equals to 0, x equals to minus 1 or 6. I'm not vibing minus 1. Minus 1 is not going to work, right? So minus 1's out. You can test minus 1. You're going to get like minus 1/6 over 1/6. It's out. But 6 works, okay? You test 6. 6 is the one. So 6 works. Let's solve the other one. Equals to, I like this 5, 6 thing because everyone knows that when you have 5, 6, the other solutions are 2 and 3. Like, you know, it's almost like a very, very common sort of trope, yeah, with the ways that factorization works out for these guys. Minus x squared plus 5x equals to 6. We got 0 equals x squared minus 5x plus 6, x minus 2, x minus 3. And yes, 2, 3. There you go. See, I can see the future, guys. Now, I'm going to assume that 2 and 3 works because we know from the diagram that there are several solutions and they're all here. So 1, 2, and 3. And we want the straight line to be greater than the absolute value curve. So between 1 and 2, and then afterwards greater than 3. So, and it's greater than equals 2. So therefore, x is between 1 and 2. Or x is greater than or equals to 3. I didn't bother checking these because I know that they're going to be correct solutions. Sorry, I need to switch back. And those are the correct solutions for the regions, for the values of x. Just fixing up that inequality sign there. Question 12. Okay, so let's get to question 13. Jamal. Hey, is Jamal back today? We've been missing Jamal. What's going on? Where is Jamal? Man, I'm doing 3U next year. Will the paper be cooked? Look, maybe they'll tone it back 2 years in a row. I can always hope. Like, remember, the harder the paper, the better it gets moderated to a better like band anyway. So question 13. So you wrote the bounds correct. You wrote the bounds. Do I write the bounds wrong? What? What are you on about? Oh my god. Alright, guys, everyone just sit back. How did a solution which involved numbers such as 2 and 3 and 6 become a 1? What's this like presenter on? Like what's he cooking? I don't understand. But thank you very much for that timely correction. So are you telling me that those diagrams were off and I was just like eyeballing it incorrectly? Like I went over to the diagram, right? And I'm like, yeah, that's a 1, 2, and a wait, huh? Everyone seen this? 3 is after 5. Why is 3 after 5? Why am I doing this? You all know what I mean. Yeah. Hey, it is what it is, guys. What can you say? Like, guy can't even count. What's he doing? 1, 2, 3, 4, 5. Not to absolutely not to scale. I mean that's exactly what I was going for there. Not to scale. All right, well, just saying, you know, no state rankings from this channel this year. We've already bombed question 10. All right, and we've also got like literally writing the answer wrong. Hey, do you reckon the HSC markers will be really pitiful and they'll be like, no, they know what they're doing. They just, nah, it's out of 3. I'll get 2 out of 3. That's awful. That is awful, man. Okay, question 13. How are we going for time? Got about an hour and 20 minutes. Yeah, question 10 wrong. Same here, Ari Berman. It's just so annoying. I didn't like that question. Did anyone in chat like that question at all? Question 10. Because, man, like, it's just a massive substitution by example. I cannot even. All right, question 13a. In an experiment, the population of insects, PT, is modeled by the logistic differential equation. The diagram shows a direction field. Direction field, interesting, for this differential equation, with the point S representing the initial population. Okay, cool. And explain why the graph passes through the point S cannot also pass through the T. Yeah, so you have to explain that that 2000, so you can say P equals to 2000, will be a horizontal asymptote, and the branch of the solutions through S. What is S? Did they even say what the initial value is? No. Through S will not exceed 2000. Yeah, I think that'll do. Number 2. On the diagram provided, clearly sketch the solution that passes the point S. I'm just going to quickly do a freehand for you guys. Um, 2000. Here is S. Did they actually provide a writing booklet for just for this trash question? They gave you like a special writing booklet. No way. What is this? That's mad. That's madness. So yeah, whatever, it's this. Okay. It's crazy. Number 3. They wasted all that paper. RGB lighting, yeah. Okay, Ace Origin liked it. Okay, fair enough. Berman didn't like it. Nope, no way. Nope. Several nopes. Okay, yes. They didn't put the center number, it was attached to the back. Oh. So do you reckon that this was an administrative issue? Like there's no center number and kids were confused? I don't know. Well, I'm glad that there's no center number, otherwise I'll get doxed, hey. Okay, good. Find the predicted value of the population at the rate for 2 marks. Why? The rate of growth of the population is largest. What? Wait. Are they for real? You have kids working their backsides off, learning how to integrate and even partial fractions, logistic functions, and they just want you to maximize a parabola. Like, what is this? Like, imagine if someone decides to integrate this all the way through and then differentiate it back. It's like you just want to maximize this. So to maximize this, you just have 2000. Look, we're just gonna graph this. So it's at 1000, guys. Like, I can't. What is this? And this is P, and this is dp dt, and obviously the value at which it's maximized is here. Here, look here. At P equals to 1000. What? What? Okay. All right. Moving on. Like, what is this? 2U paper LOL. Ari Berman, yeah, I started doing partial fractions and then I was like, wait a minute. Tomo QX did not cooked, not a 3-unit paper at all. This had some really easy questions for no reason. Should have been 1 mark, yeah. Like, imagine if someone decides to dive in and start doing this, and you know what's gonna get worse is they get the logistic function, and they'll find the time at which it's maximized, and then they'll sub it back in to find the population. Like, imagine the trauma you'd be in. Oh man, like, what is this? Okay, whatever. You know what? This is quickly turning into one of these, what do they call it, speed runs now. I don't know, this has been an easy paper, like, across the board. Probably not a bad thing. So, generally when you look at these questions, right, like, unless you're some sort of, like, genius that looks at this and goes, I'm cooking this. Does anyone cook like this? Who cooks like me? Anyone cook like me? No, look, I'll just write it anyway, whatever. Alright. Yeah, let's do that. Yeah, sure. Squared minus... yes. and we're going to change that into a 1 minus cos. So look, honestly, like at this point, you can even like go something like stupid like this. You can be like, hey, let's make this a sine double angle. Let's make this sine 2x except squared, except like over 2, right? And then like, yeah, why not? And then you can be like, common denominators this, and go like 1 minus cos 2x squared. Yeah, sure. Okay, no guys, this is not an official solution, but hey, we got it. Equals right hand side. All right, we're just showing off now. Hey. Yeah, no, it's the answer, guys. I think we're fine. We're fine. LMAO, yeah, yes. No, you've written the right hand side wrong. Oh, you know, I got a 2. I just didn't write it. My bad. I didn't care about the right hand side anyway. Like, clearly the right hand side is beneath me. All right, guys. This is how you do the left hand side. This question got picked up and thrown at the wall, didn't it? All right, here we go. Yeah, that was merciless, I would say. All right, here, let's integrate. If you do the right hand side, does it come out okay with the right hand side if you just like double angled it, guys? I'm pretty sure it's fine, right? Like there's nothing weird. You just like expand it thoroughly and wait, WTF? Bros back for revenge after 4U. Yeah, exactly. We ain't messing around. Okay? This is how you factorize the sum of 2 fourth powers of anything. By the way, guys, if you ever wanted to like learn about this through your journey at school, you learn this in the Australian Maths Trust Year 9 book, NERTA, the enrichment stage. You open up that book, you learn about all the secrets to factorizing things that a mere school child cannot factorize. So yeah, I think one day if you're ever interested, get some publications from the Australian Maths Trust. That's where the real brains of the country are. So let's integrate. 1 plus cos squared 2x dx. Still not comfy about this. Like, I just don't enjoy doing the whole, like, whatever. Use your reference sheet, guys, if you're not sure what's going on here, right? Just take it easy and make sure that you've got all the correct coefficients. So we've got a half plus a quarter, so 3 on 4. Okay, cool. And we got a quarter cos 4x dx. I'm pretty sure I made a fraction error somewhere, but let's keep going. I don't know. The halves look scary to me. I'm scared, guys. Yeah, okay, no, I'm gonna take it. 3 on 4 x plus 1 on 16 sine 4x from 0 to pi on 4. Alright, well there's zeros on the sine, so at least it's going to be 3 pi on 16 plus 1 on 16 sine of pi, which is 0, and minus 0. So just 3 pi on 16. Alright, part C. Time to go back to year 9. Let's go. You start UCAT practice in year 9. You got it. I was off by a factor of 2 somehow. Yeah, it's this part. It's this part that's really scary. Like, because you got a half from the formula sheet, and you got another half from the half times cos squared. So there's a bit of a trap here. Like, I feel like the way that they've written it as like a little like giant fraction did not help anybody. Yeah. Okay, vector A is 1, 3, and vector B is 2, minus 1. The projection of vector x onto the vector A is Ka. So let's just quickly check something. 1 across and 3 up. This is vector A. And we got a vector B, which is 2 across and 1 down. So I'm gonna like guess it's like this, vector B. The projection of a vector x onto vector A is Ka. Yeah, okay, sure. Let's just make vector x a fairly neutral spot. What do they mean by this? Are they just asking us to use two formulas and simultaneously solve it? I feel like this whole simultaneous theme has been going on. By the way, I had another go at the question 14E from the extension 2 paper, and honestly, how do you teach kids, how do you teach someone that when you've got the centroid of a triangle and you've got all these lines going on, that you require two simultaneous variables and you need to like I don't know, is that something that like a kid can actually intuit? What do you guys think? Like, for those of you who did the 4-unit paper, do you know what I'm saying? Like, how do you get someone to like come up with two simultaneous ones and then later on do it again without any like sort of scaffolding? I just find it's such a, like, I wasn't confident enough at it in my attempt during the paper, but later on I thought, yeah, but like that's a lot of experimentation unless you're like already quite experienced that type of problem. Okay, so let's just do the thing here. Oh yeah, this one took ages. Teach linear independence. Yeah, but here's the thing, like when you have A and B are linearly independent, like that's a theoretical thing to do with bases of a number plane, right? I do not even think that's like that featured in the syllabus. Like, do you know what I mean? Like, how do you make A and B a basis if you don't even use that language? I think I just did it differently. I don't know. Just did the first step. Just turn it into position direction. Oh, I'm not a fan of positional direction. Hey, let's just do it with a projection formula, guys. So x, I'm gonna call vector x, and I'm gonna call it like why did they use x? It's so dumb. Can we like find vector x? All right. We use m and n, I guess. Let's go. So the projection of x onto A equals to, what's A again? 1, 3. So we got x on A, m, 1m plus 3 times n over A dot A squared plus 3 squared times by 1, 3 equals to Ka. I don't know if I'm wasting time or not doing this, but we better have a go. And similarly, projection of B, x onto B equals to something similar, 2m minus n over 2 squared plus 1 squared is 5, with A 2, 1, 2 minus 1, which equals to P of vector B. Now A is just 1, 3, so really the coefficients is what we need to equate here, and the B is like 2 minus 1, so it really did not matter. Like, this is just theoretical, and we just got these two simultaneous equations. M plus 3n equals to 10k, and 2m minus n equals to 5p. So in order to get m, we eliminate. So this is for children who are like scared of elimination method. You need to be an expert at elimination method. Okay, take equation number 2 times 3. You're going to get 6m minus 3n equals to 5p. Because if you do it the other way, it'll work. You just have to make n the subject to eliminate it. But this is much faster. Okay, and you add equation number 1. And we're going to get 7m equals to 10k plus 5p. M equals to 10k plus 5p over 7. And the other one, we're going to have to do the same thing with equation number 1 times 2. You're going to get 2m plus 6n equals to 20k. And you subtract equation number 2. You're going to get 7n. 7, is that a 7? 7n equals to 20 minus 5, so 20k minus 5p. I mean, overall, a rather tedious question, but hey, very doable. It's just instructing you to solve some equations in terms of, you know, k and p. So in the end, k and p, even though there were ratios, like even though there were like scalar multiples of these vectors, ends up becoming the actual values of x, which is interesting. I didn't expect that to happen. Okay, so vector x is going to be the following two things. I'm not going to bother writing them again. Yeah, why not? and J. All right, there we go. So that's that one. I don't know, a bit of a bash. 15p. Did I stuff up something? Yeah, I did, didn't I? I didn't even times it by 3. Thank you very much for that. Thank you. So let me just think. We add equation number 1. 15. 15 everywhere. 15 here. Yay! Amazing. Thanks very much, Kushal. If it wasn't out of those 4 unit questions, would be a lot better. Those 4 unit questions a lot better. IQ. Hey, so you reckon those questions are a lot better if you were to teach? Yeah. It's unfortunately, we're using this app called GoodNotes, which is one of the 2 main apps for note writing on the iPad. Using the substitution now, this one I was looking forward to doing because it looked quite interesting. U equals to e to the x plus 2 e to the minus x, and considering u squared. So they literally spoon-fed it to you. U squared equals 2. Now let's have a go. E to the 2x plus 2 times e to the x times 2 to the e to the minus x. Ooh, okay, that's pretty cool. Plus 4 e to the minus 2x. So this middle term here has all but disappeared. It's become a 4. And you got 4 e to the minus 2x, which is literally almost the denominator, if you sort of spot the kind of thing there. But it's a little bit strange looking still. Okay, let's try integrating. I'm curious on what the real substitution is in this situation here. I'm not seeing it straight away. Let's find out. One thing we do need to do though is this, and this is kind of like important because we're trying to convert dx to du, so we need to do du as well. Du equals to e to the x minus 2 e to the minus x dx. We're going to search for this. Okay, we're going to look for this to make it absorb into the du, and we found it in the numerator. So we factorize out the e. Actually, did we? We do if we divide by e squared. Which is really strange because, like, I don't know, this is not that easy to spot. You're going to divide by e to the 2 of 2x on the top and bottom of this fraction. I think that's not obvious. Look, if you don't do it, you're going to have to struggle doing this. And one thing that you can do is you can attempt to like make dx the subject as a backup. If you're a person who sort of like has trouble seeing how to find like, you know, the combination that makes du, you can always make dx the subject, bring this to underneath du, go in there and really find a way to make these guys line up. Or you can factorize out e squared, e to the 2x. But the ideal way here is to just divide through by e to the 2x because you get something that you like on the bottom as well. Do not tell me I stuffed up. No, I shouldn't have stuffed up the bottom, which is strange. Anyway, here we've got e to the x, 2e to the minus x, and that's going to be dx. That's going to be du sorted. Okay, on the bottom, we've got 4e to the minus 2x plus 8 plus e to the 2x, which is pretty much everything we have for u squared except the us plus 8. So on the top, we just got du. On the bottom, we have a u squared plus 4. So obviously, giving you that substitution and giving you the hint to square u is what you need to do this question. I think I've got everything there. So du, no, we've written du already. Okay, and that equals to a half times inverse tan of u over 2. And afterwards we can simply plus c. We can simply like put u back as what they gave us, which is e to the x plus 2e to the minus x over 2 plus c. All right, so that's question D. We're up to question 14 now. Let's have a look at some of the delights. I found M and N, didn't write it. Will I lose the mark? Cluggy, that's a shame. I hope you got the same values for M and N as I did. The question was out of how many? 4 marks. You did all the work, man. Like, I can't tell you whether I think you will or not. Like, I'll be a bit like annoyed if I didn't get 4 out of 4 because you basically, you found the components of X. And if you were a marker and you're looking at this, if the student has clearly found the components of X, I don't think a mark should be the benchmark for actually like writing it. But hey, it depends on the people marking. It also depends on how many papers they go through that has your issue during the pilot marking. So I can't tell you for sure, but all the best, man. Like I hope you get the actual full marks out of 4 for that one. Yeah, good luck. Okay, question 14. Let's go. How are we doing for time? I feel like we've been like breezing through this. We've got a whole hour to do question 14. I mean, we can always just have a explore about what are some of the cool things about question 14. Find the domain and range of the function that is the solution to the differential equation. So we've got dy dx equals to e to the x times e to the y. Okay, the natural thing to do is just to separate the variables. So we got 1 on e to the y dy equals to e to the x dx. We can have e to the minus y dy equals to e to the x dx integrated, which is going to be minus e to the minus y equals to e to the x plus c. Domain and range of the function that is a solution. I'm kind of like a bit worried about this plus c. I have a feeling whose graph passes through the origin. All right, we'll just okay, well, they give us c for free. I mean, we take it, right? So minus 1 equals to 1 plus c, just take it easy, minus 2. So minus e to the minus y equals to e to the x minus 2. I'm a bit scared by this. There's something like not quite right, and it makes me not want to make y the subject. There's just like, I know something dodgy is going on, so let's talk about the domain and range here. So looking at this like an inequality, we know that this thing must be less than 0, okay, because it's an exponential function. So as y varies, when we're doing domain, we're always interested in the allowable values of x. But in this question, we're actually very interested in what x turns out to be as y varies. And this is an exception to how we normally find domain. It's not an algebraic thing. It's a graphical thing. E to the x minus 2 must be less than 0. E to the x must be less than 2. And x must be less than ln of e. Okay, you ln both sides, which is an increasing function, which keeps the inequality sign intact. That's the domain. I'm just quickly checking if there's any like particular like minimum bounds for x. I feel like you wouldn't, because you could have a very, very negative. Let me think actually. So e to the x is less than 0. E to the x minus 2 is. Can x be very, very negative? Yeah, why not? It's fine. Okay, now let's look at the range. The range is now, we're talking about e to the y now. I'm going to quickly move it to the other side. E to the minus y equals to 2 minus e to the x. So in this one, we have a graph of e to the x with a horizontal asymptote at 2 and going underneath like this. So normally we have like this, we flipped it so it looks like this with a 1, and we know this is actually less than 2. So e to the minus y is less than 2. I'm a bit worried about logging both sides, but I feel like it's still legal. You can ln both sides, all right? So minus y is less than ln of 2. So y is greater than minus ln of 2. So I'm going to take that one as well. So my two answers are domain, x is less than ln of 2. Did I write ln of e? I don't know why I did that. ln of 2. And the range is y is greater than minus ln of 2. That's, you know what, like, hey, for a domain and range question that's quite like advanced, you know, not a bad question. I mean, hey, what do you guys think? Was 14A doable? He miswrote it? Yeah, my bad. F, I could have gotten that so easily. Eternal will education. I got the 14B wrong 100%. Bummer. Sorry to hear. Despite it said is a solution. Yeah. Is the solution. Look, yeah. Muhammad reckons it's a good question. I like the way that it really tests people's understanding of domain and range beyond simply algebra, right? It's got to do with the way that this graph plays out. That the way that there are restrictions to what this can be, which helps you get this, and there are restrictions to what this can be, which helps you get this. Very cool. Okay, fantastic. So number B, for what values of the constant k would the function have an inverse? So here we've got a function of kx over 1 plus x squared plus inverse tan. They love the arctan notation here. Inverse tan have an inverse. My opinion with these questions is always to have a little graph trying to figure out what's going on. But I am sort of like vibing something to do with this derivative. But I'm just going to quickly sketch it just to show you guys. So we got a minus 90 to 90 pi on 2 to pi on 2 inverse tan graph. Okay. And we've also got, obviously defined for all x. We've got the other kind of graph, which is a asymptotic graph with an odd function, which means that if you had k, it'll make it steeper at the origin, but it does go through the origin, and as x is positive, there's probably like something like this going on, yeah, and something like this going on, just on a quick graph. And if we were to add them, right, if you were to add these two functions together, you want this function to pass the horizontal line test, which means that something around here would have an issue passing the horizontal line test if you were adding them. So what does that mean? It means that you want this graph to have no stationary points. Because if it's no stationary points, then you can further on argue that like f of x is always increasing. So having realized that, we are going to attempt differentiation, and I'm just sort of like, there is no real good way of actually graphing and adding these coordinates because we don't have any coordinates to work with. So I'm going to go y dash. Quickly doing the quotient rule. And you know the quotient rule is looking good because the arctan is going to give us 1 on 1 plus x squared over here. So this is a good sign. And we have 1 plus x squared, okay? And we're going to times by k. No, we put k aside, so 1, and then x times 2x on this one. And we're going to have k. And over here, we have a 1 plus x squared minus 2x squared over this stuff squared plus 1 plus x squared. And we're going to try to make everything on the numerator. So here, we've got k bracket 1 minus x squared, because it's x squared minus 2x squared, so it's 1 minus x squared plus bracket 1 plus x squared, 1 plus x squared squared, okay, yeah, and we want this to be always increasing, always decreasing. So we'll do case 1, always increasing. Equals is okay as well, I think. Wouldn't risk it, but let's do an equals. I think equals is okay. Let's try it. For what values of the constant k? But I'm like kind of worried about this now. Because how do we even solve this? Getting a bit bogged down by this. Let me think. What values of the constant k would the function have an inverse? Look, if k is 0, it's totally fine, right? I mean, what if k is 1? K is 1's fine as well. You know what? We just have to commit. We have to be like, move this to the other side. And that's going to be the same as, say, 1 plus x squared over x squared minus 1. And we're going to have a, what's it called? We're going to separate this by going, okay, 1. So k needs to be greater than this. Interesting. It's going to be 1 minus 1 plus 1. So it's going to be plus 2. Sorry, I just split up the fraction a little bit. K needs to be greater than this. But by dividing over, haven't I stuffed up the direction of the inequality? You can't just do that though. That's the issue. You can't actually just do that. Let me just check if there's a mistake in my differentiation here. Quotient rule. Yep. 2x squared. Okay. Time. Yeah, we've got time. Minus x squared. Yep. Okay, interesting. I'm a bit concerned about this. I'm looking at this and I know like this is what we're seeking out. We want to sort of find a value of k so that this is either always positive or always negative. But how do we do that? I'm not keen on this like inequality. So something's bad going on. Something bad's going on, guys. We actually need to like use our brain cells a little bit at this point in the exam. So we know that when k is greater than 1, this is not great because you're going to have like a negative something x squared. Why don't we just treat it like a quadratic? Okay, so in my red pen, I'm just going to show you guys the quadratic here because this is what's going to be plus 1 plus x squared. Okay, and we basically do not want this to have any intercepts. Basically, we want this to have no roots because that way we can either have a quadratic that's like this or we have a quadratic that's like this. So yeah, I feel like this is the way. I've made that realization and I've made that determination. I was just a little bit like reluctant to expand this and turn it into an actual quadratic because I'm like, if we can just, you know, like finesse out the k values by looking at this, but hey, if they want us to brute force a quadratic out of this like, you know, very like, you know, indirect kind of question, good on them. Like props that they made an interesting question involving a quadratic in a 3-unit like third last question. Okay, so we want this to have no real roots, which means the discriminant, which equals to b squared minus 4ac, which equals to 0 minus 4 times 1 minus k. I'm just checking if my coefficients are correct, just one last time. And a k plus 1, yep. K plus 1 equals to minus 4, 1 minus k squared. Okay, so this is 4k squared minus 1, which we obviously would like to be less than 0. And here's another quadratic. We did one earlier in the paper. Minus 1, 1, less than 0. So it's the section in between. I thought as much because even while inspecting this expression, I kind of realized that if k was somewhere like 0, this thing will take over and create a nice positive parabola. But if k was like greater than 1, you're going to have like a negative parabola that's going to have intercepts galore, right? So I kind of like had that intuition, but having a discriminant to solve for us makes this all the better. And the answer is between like this. So this is the value of k that I found. Yeah, fair enough. Still not a bad question. I think question 14 is where they're going to decide pretty much all the sort of the top E4 sort of marks over there. Not bad. Any comments? What do you guys reckon? Bro, Swifty, shush little bro. Hey Swifty, welcome back. 14D was surprisingly not hard. I feel the hardest question is this one. Yeah. Hey Ari, yeah, I spotted the discriminant. Probably best question in the paper. Look, honestly, not easy to find. But given that it's out of 3 marks, what would you guys say this will get you to? I feel like you need a bit more than this to get 2 out of 3. So maybe if someone intuits a particular set of values for k here, they can get the 2nd mark. But to really get it, I think you need to like get the discriminant idea. Pretty cool. Yeah, why not? Okay. Question 4, part C. Explain why the equation equals theta, where theta is between minus pi to pi, has exactly one solution. So this is one of those ones where you can actually have a graphical argument for this, in my opinion. But don't tell me I have to like use the same concept. Whatever. Okay, theta. So my graphical argument will look like this. you're going to have tan inverse 3x, which is horizontally dilated by a scale factor of a third. So we're going to have this tan graph, all right, between pi on 2 and minus pi on 2. We're going to have a slightly more dilated horizontally one, like this one, okay, and that's going to be the other one. And then you can say something along the lines of that the tan inverse of 3x plus tan is an increasing function. So it's a very similar idea to the previous one, that in order to have an inverse, you want to be 1-to-1. So you want to be monotonic increasing. So this one's monotonic increasing, and therefore when it equals to y equals theta, you're only going to have one intersection point. So that same idea in question C, which is, I don't know about how I feel about that, because it's a bit repetitive, but it is what it is. So hence we're going to solve this equation. These ones are like bread and butter. You basically let alpha equals to tan inverse of 3x, just to save yourself some writing later on, and beta equals to tan inverse of 10x. And you're going to go tan alpha plus beta, which is what we're going to do. You're going to tan the left and right hand sides, equals to tan 3 pi on 4. Tan 3 pi on 4 is -1, so we're going to have a boring equation to solve. -1 here, tan alpha plus beta is the compound angle formula. You're going to have tan alpha plus tan beta over 1 minus tan alpha tan beta. And that's going to be 3x plus 10x over 1 minus 3x times 10x, which equals -1. So 13x equals to -1 times 1 minus 30x squared. Right, okay, so, I mean, sure, this can't be anything else, right? Like just another quadratic? Question mark? Non-monic quadratic? Any sums, products, factors, chads here, or anyone who do the cross method? Look, honestly, anything will work at this stage. I'm going to do products, the sums. Products, minus 30, sum, minus 13. You've got a minus 15 and a 2. 30x squared minus 15x plus 2x minus 1. And we're going to have a 15x common factor. 2x minus 1 plus 1, 2x minus 1. Cruising, everyone. We're just vibing along. No tilt this exam. We found, I think, the answer to the hardest question according to the chat. So, and got -1 on 15. Now, of course, there's only one solution. So what solution would that be? Because we can only accept one of these. So you can like just test it, honestly, right? Let's have a look. So if you do like tan inverse of 3 on 2 and plus tan inverse of 10 times 10 on 2, I feel like these guys are both sort of in the range of 0 to pi on 2. This one's from 0 to pi on 2, and this one's from 0 to pi on 2. So adding them together, you get 3 pi on 4. I feel like that's fine. But if you do the other one, you're going to get like a whole bunch of negative angles. So this one's not going to work, right? Because -1 on 15 just won't play well with these numbers. So it's not going to work, and we know we can reject it because this one's from like in the negative, like in the 4th quadrant. So it's not going to be good, and we can ignore it because it's going to be like less than 0. Like if you put this in the calculator, it's going to be less than 0. Therefore, x equals to 1/2. All right, and we're done with that one. So x is 1/2 for second last question, and we're up to the 4 marks at the end with the projectile. All right. Yes. All right, I don't even know what this guy's on about. Chat Ron stream, yeah, Fortnite balls. Interesting. Any Fortnite enjoys here? You know, I played Fortnite back in like 2018 when it was actually good. Now it's like, I think people just buy skins. Question D. Wasn't any good at building though. Building's hard, guys, unless you've got like macros programmed. D. This ain't even a projectile question. All right. Let's find out what it is about. So when we were reading the reading time, we sort of thought that the distance of the displacement vector, So what they're saying is, here's the x and y coordinates, right, as the thing is going through the air. So if this is x and this is y, then we're saying that the displacement vector according to time t is this. And they're actually interested in this particular distance. Oh no, let's try that again. This. Okay, and that's going to be like distance with respect to time. So they just want the magnitude of that, position vector, and all it is, it's going to be a square root of the thing. I've not left myself enough room to do this square root, so I'm going to draw a giant square root sign. Guys, how big can a square root sign get? Let's go. V squared t squared cos squared theta plus v squared t squared sine squared theta minus, v. Do not tell me I have to cube it. No, please don't. V g t cubed sine, I'm just doing the perfect square in my head really quickly, plus g squared t4 on 4. Simplifying down to, there's a 1 here, so v squared t squared minus vg t3 sine theta plus g squared t4 on 4. Something tells me that this is some stupid factorization that we just have to see and then we're home free. But not yet. No, something tells me this is about discriminants again. Why? Alright, show that from theta equals the distance is increasing. So we want dt to be increasing for all t greater than 0. So d dash t is greater than 0. Sorry, increasing for I low-key do not want two different. Oh, come on, for all t greater than 0. But okay. Let me just check some stuff here. So v is a constant. This is some kind of thing here. It's a discriminant. Like, what is up with that? Guys, I'm just gonna do d dash t. Like, and this is how you do d dash t, guys. You can be like d. Like, the two ways to do about it. One way is you can just be like, hey, we know we're not going to care about the denominator. We're just going to write a big square root sign, and it's all that stuff we've done up here. And we differentiate, we got a half, so we don't really care about the half either. All we're really interested in is the quotient, the chain rule on the top, which is 2v squared t minus 3vg t squared sine theta plus 4, which cancelled out with the 4 on the bottom, so that's gone, g squared t cubed. We can even factorize the t out because that t is a positive, so it's always going to be not a problem to us. 2v squared. You know, we're even going to like make it in quadratic form. G squared t squared minus 3vg t sine theta plus 2v squared and over 2 of the root, which all of these things are all positive anyway. And we want this to be greater than 0. So therefore, we want this expression, g squared t squared minus 3vg t sine theta plus 2v squared to be greater than 0 for all t. Is this another discriminant? Like, come on, like, do we really? Oh man, like, okay. So discriminant equals to b squared minus 4ac equals to 3vg sine theta squared minus 4g squared times 2v squared. We got the 8, we can see the 9, we got the 8, we got everything. Lock it in, everyone, lock it in. It's another discriminant. What a shame. Can they get... Did they go through this with each other? Like, what's up with this? No solution, because we want this to be above. We want this again, right? So here it is. Divide the v squareds through. There's no v squareds. There's not even any g's really. So divide all those through. You're going to have 9 sine squared theta less than 8. Sine squared theta less than 8 or 9. And considering that theta is acute, we can safely say that sine theta is less than root 8 or 9. So theta is less than inverse sine, which is an increasing function, so no issues with the square rooting. Yeah, I guess that's the end. How much time do we have left? We had like 32 minutes left of this exam. What is up with that, guys? Like, there's no variety. We've seen like how, okay, so going back over it, we went like, we went over this, right? We went like discriminant, quadratic, question mark on question. So guys, let's just going back over all the questions. Like if you really like quadratic, you would have a field day with this exam, right? Like, so 14A. 14A, low key, is not a quadratic. It's a nice question with domains and stuff, which is not bad. 14B, quadratic. Discriminants. 14C, a quadratic equation requiring solving. 14D, a quadratic discriminant involving the derivative. What paper are we doing, bro? Recheck 14B. Yeah, not me. What do you reckon? 14B, I've got it between -1 and 1. But how did you get the paper already? I think apparently, according to one of the YouTube comments, we hijacked a van containing the papers. This exam, Jack, would have been of -1 and 1. It should be inclusive. Do you reckon? Let's have a look. Actually, we got a question in chat from not me. He reckons it's inclusive of -1 to 1. Yeah, you might have a point. Let me just check something. Let's say it equals 1. You know, you're right. Hey, good spot. Beautiful. Thank you so much for that. Because if k was 1, this is actually a boundary condition where the numerator is not a quadratic. It's actually a constant function. And the numerator is actually 2. So y dash equals to 2 over thingy, which is also positive, always, so monotonic increasing. So you're right. We need to actually do this after considering the fringe cases by considering the boundaries. Because in these situations, it's not a quadratic. Very excellent spot there from not me. Look, yeah, guys, did we all pick that up? Like, so the intuition when I was trying this out, I was like, 1 is something special. There's something special at 1, and you heard me say it, but you know, I'm just hot coping right now. I'm just like going, yeah, surely I saw that, but I didn't write it out. I got too excited over seeing the quadratic discriminant that I didn't actually spot the need to consider the case where we're on the boundaries, where this devolves into a horizontal line, okay, on the top. So thank you very much. It's inclusive for 1. I better check -1 too, shouldn't I? If I check -1, I'm going to get 2x squared. To be honest, 2x squared for, what is the x values for this question? Let me check, actually. Dash. Nah, -1 still works, man. Because when you have -1, what you have is, if k equals -1, y dash will be, you can actually have like a 2x squared on the top, right? And when you have 2x squared on the top and something squared on the bottom, yes, there might be a moment where in the neighborhood of x equals 0, that it's horizontal, it's got a stationary point, but we're still okay. This could be like a, you know, what they call a non-horizontal point of inflection, because rest of the time it's still positive. So even though it's like monotonic increasing everywhere except there, the part where it's like horizontal is okay, because it only happens at that exact dot, and you will still pass the horizontal line test. Does that convince you? Ari, does that convince you? Like I'll give you a graphical example of that. So for example, if you had a graph and the graph is increasing, 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 but somewhere here there's a horizontal point and then it continues to go on increasing, this point should still pass the horizontal line test. So I think we'll be okay. Like, yes, but hey, I wouldn't have got that last mark on out of 3. So I guess we can say that just doing the quadratic discriminant only gave us 2 out of 3. I think that mark, that last mark of considering those boundaries and actually have an intuition around what values of k makes this not a quadratic, that will be a state ranking mark for sure. Like I think if someone picks this up, which not many people would, I think, and they got everything else in the paper right, that's what it's going to take to get the state rank in this year. Hey, you might get like 20 state ranks for this paper, who knows, right? Yeah, so we had 3 quadratics in the last question. And then, before that, we could call this a quadratic, you know, like this one, because it's got a little bit of, you know, it's got some U substitution. Yeah, well, you would barely call that. It's just a quadratic expansion. This one can take a little while because the answer's in terms of M and P, K and P. What I'm interested in is that it's how like the K and the P are actually just scalar values, but somehow the answer is just a scalar value, and it wasn't in terms of A and B at all. It was just a particular combination of K and P that are very arbitrary. Like you basically designed K and P in a way that makes X, and that's it. There's no real connection to A and B as a diagram at all. If you have a look at the solution here, this X could be anything. Like there's no connection to the A and B in some geometric kind of way, because we got the big geometry question in the 4-unit paper instead. So that one's fine. But yeah, I got to say the most exciting question. Please, no, don't tell me about this one. Like this one is just, are they joking? They got to be joking. And question 10 was not very impressive either, right? So question 10 was not great. It was very like substitute by example. Hey, if that's what the multiple choice technique you need to get the question out securely, by all means. I had the technique. I just didn't have the angle solving skills to get the correct angles because I didn't read the question. It's up to 2 pi. It's not in the last. It's not in the 4th quadrant going negative. So yeah, I think this solution is pretty complete now. We've got like 25 minutes left, and there's not much to say apart from, hey guys, check out the disgusting factorization of the left hand side. So yeah, that was good fun. What would a 68 out of 70 go to? Yeah, I'm hoping for the best. Like I'm hoping, Muhammad, that you get your 99. Extension 1, you know, you tend to like get a 99 if they, you know, if you're close. Bro, stop showing me that integral. I'm still mad at forgetting to divide by 2 in the bracket. Oof. How did you find this comparison to my attempt of 2023? A lot easier. This paper was just a whole different level of easy. I keep asking ChatGPT and it's saying not k equals -1. Yeah, but ChatGPT has this like, it's not thinking in a mathematical theoretical way. ChatGPT is basically, it's just using a very like rudimentary logic brain with all the sort of Wikipedia knowledge. I would not even consider ChatGPT for doing maths. Yeah, like what Muhammad said pretty much. What was it compared to 21 and 22? Look, any year where the last question is a disgusting combinatorics question or a sample proportion question involving heavy comprehension, this is easier, right? So I would say this has been the most accessible, easy to score over 60 paper in the new syllabus. Any ones in chat? Ones in chat if you guys agree. This has been like this has been a free paper. It is 4 pi. 4 pi as the answer. Which question are we talking about, Jamie? Ones in chat. Here we go. Yeah, exactly. Free paper, guys. Hey. 4 pi. I'm just checking what Jamie's referring to, which question he's talking about. I can't actually see anymore. Yeah. Question 10. I put 4 pi, didn't I? I put 4 pi, guys, which is D. I did D. Yeah. No, it's actually 4 pi. Yeah, unfortunately, I stuffed up, guys. I actually screwed up. It was D, and it's because, like, yeah. E4 cutoff. Need at least 60 for this one. 60. Alright, so I guess with this on the screen, I'm going to leave you guys to just, yeah, celebrate your HSC. Good luck for the rest of your exams if you all have some left. And till next year, everyone. Catch ya.